So today's lesson is our 3 notes on proofs. So on the AKS was MAGS B3D, and it says prove and apply theorems about lines and angles to solve problems. We're going to use some of the relationships that we've already learned about. We're going to learn a few new things today, and we're going to do some algebraic proofs, okay? So by the end of today's lesson, you should be able to recognize and use the properties of equality and prove that corresponding angles and alternate interior angles are congruent in a two-column proof. And there are different types of proofs, and we're just going to talk about two-column proofs today. So a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. So your blank in your notes shows that word proof. The next thing in your notes is a theorem. A theorem is a statement that has been proven to be true. So this is something we already know is true. It was been proven at a previous time, okay? Two-column proof is a style of proof in which statements are written in the left-hand column and the reasons are written in the right-hand column, okay? So what we're going to do first is we're going to talk through what these properties look like, okay? Because we're going to, when we do these things in a proof, and we're going to do some algebraic proofs first, I want you to know what it looks like, okay? So first of all, when we talk about an addition property, if we say A equals B, okay, go ahead and write that down. Then if we were to say that A plus C is equal to B plus C. So what did I add to both sides? The C. Y'all see that? Okay. So how does this look in a problem? So the way this would look in a problem is x minus 2 equals 5, right? So what do we do to both sides of this? Don't we add 2? So we would add 2 here to both sides, right? So that would be the addition property. So our answer would be x is equal to 7. So if we were trying to explain what we did from one step to the next here, it would be the addition property, okay? So on this next one, again, we're going to say A equals B. If A equals B, then what? This is subtraction now. We're going to say A minus C is equal to B minus C, okay? So what does that look like? So that looks like this. So if we were to say x plus 2 equals 5. Now what did we have to do to get rid of the 2? We have to subtract it, right? So we're going to subtract 2 from both sides. Minus 2, minus 2. So here, x would be equal to 3. And we had to do subtraction to simplify that problem, okay? Now at any point going through this, if I'm going too fast, you guys need to pause the video, okay? All right, so the next one is multiplication. So once again, we're going to say A is equal to B. If A is equal to B, then A times C is equal to B times C. Okay, so let's talk about what that looks like. So on this one, we're going to talk about 1/2 x equals 2. So how do we get rid of that 1/2? What's the reciprocal of 1/2? It's 2, right? So we're going to multiply both sides by 2 here, right? And when we multiply 1/2 by 2, that would give us 2 over 2, which is 1, right? So that's going to give us x equals 4. Okay? So once again, did everybody get that? Okay, all right. So division. So now we're going to say if A equals B, then when we're talking about division, A divided by C is equal to B divided by C, right? Okay, so how does this look in a problem again? So this would be like saying 2x equals 4, right? So what would we do with both sides? We would divide both sides by 2, wouldn't we? So then that's going to be x is equal to 2, right? We could keep putting the word so in here, y'all, but I think y'all understand how that works. Okay. The next one's the distributive property. Okay, so on this one, we're going to write it a little bit different. So we're going to say if A times B plus C, right? If we do A times B plus C, then what? Then AB is A times B plus A times C, right? Okay, so how does this look in an actual problem? So we would do 2 times our, let's just say x plus 3. We're going to distribute that 2, right? So it's going to be 2 times x plus 2 times 3, which would be equal to 2x plus 6, right? Okay, that's the distributive property. And again, we need to pause a minute so you guys can write this down, then go ahead and do that. The last one on this is the substitution property. Okay, so when we talk about the substitution property, if we say that A is equal to B, then what? Then B is equal to A. Now let's use this in a problem. So if we say that X is equal to 2, then 5x plus 1 is going to be equal to 5 times 2 plus 1, which would be what? 10 plus 1, which would be 11, right? So we're doing the substitution property. We substituted in the 2 for the x and the 5x plus 1, right? Again, pause the video if you need to so things can be written down. So remember, we defined what a proof was earlier as an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. So how do we set up a proof? That's the next question. So we're going to think of proofs like a game. So the object of the game is to have all the statements chain linked, okay? Right there, chain linked, so that one fact leads to another until you reach the proven statement. So before you start playing the proof game, you should survey the playing field. So that would typically be your figure or the given information. In a lot of cases with these proofs that we're going to do, we're going to have a figure, okay? So you look over the given and the proven parts, we're going to talk about that a lot, and then develop a plan on how to win the game. So once you lay down your strategy, you can proceed statement by statement, carefully documenting your every move in successively numbered steps, okay? So statements made on the left are numbered and corresponded to similarly numbered statements on the right. It's all going to make sense in a minute, so just give me a minute. All statements you make must refer back to the figure and finally end with the proof statement. The last line under the statement column should be exactly what you want to prove. Okay, now we're going to talk about this more as we work into this, but so we're going to first start with an algebraic proof. Okay, so this basically says when solving an algebraic equation, justify each step by using a definition, property, or piece of given information. So example 1 says solve for x, right? So, okay, this is what we're going to do. So we're going to work through this together and we're going to write steps. So our second step here is going to be what? So what would you guys do first? I would do something to get rid of that 1/2, okay? So I'm going to multiply both sides by 2. So I'm going to multiply this by 2, 2x plus 5. Remember, what do we do on the left of the equal sign? We got to do on the right. And we're going to also multiply the 1/2 x minus 1 times 2, okay? So the first step was given. So I want you guys to write that. In most of the time, in most proofs, y'all, their first step is going to be given information. Okay, that was just given to us. So step 2, what do we do here? Aren't we multiplying both sides? So this is the multiplication property. Okay, the multiplication property. And you could write property. I'm just going to write prop, okay? All right, so then the next step here, 3, is the distributive property, right? Isn't that what we're about to do? We're going to do 2 times our 2x plus 2 times our 5, right? Equals 2 times 1/2 x, minus 2 times our 1. This is the distributive property, okay? I can't write very well today, y'all. Distributive property, okay? Distributive. T-R-I-B-U-T-I-V-E. Okay, so now we're just going to simplify that, right? So that's going to be our next step. So we're going to have 4x plus 10 equals, and then half of 2 is 1, right? So this is just going to be x minus 2. So this was just simplifying. That's all we did here, okay? Was simplify. Okay? Then our next step, we're going to start moving some stuff, okay? So I am going to subtract the x from both sides, okay? So with number 5, I'm going to subtract x. So I'm going to do 4x minus x plus 10, and that's going to be x minus 2. Now, typically y'all would do this horizontally, right? I mean vertically, sorry. So we did the subtraction property because we subtracted x from both sides, okay? Okay, so that gives us, again, we're going to do some simplifying here. So this is going to be 3x plus 10 equals negative 2, right? So didn't we just simplify? That's what we did. Okay, so now what are we going to do next? I think we should subtract 10 from both sides, right? So step 7 here, we're going to do 3x plus 10 minus 10 equals negative 2 minus 10. So that is, again, the what? Subtraction property, right? So for step 7, we're going to say subtraction property again. And I'm being very detailed with this, y'all, so you guys can see everything. So once again, what are we going to do for step 8? We're going to simplify, right? So this is going to be 3x equals negative 12. So that's going to be simplify. Okay. And then step 9, what are we going to do in step 9? We're going to do 3x divided by 3 equals negative 12 divided by 3. So that's going to be our step 9. So that's going to be division property, right? Okay. And then step 10 is going to be simplify again, right? So this is just going to be what now? X over here equals negative 4. So step 10 was simplify. Now, some people might do this in less steps. I gave you literally every single step in the explanation of every single step, okay? So if need be, pause the video here and write down what I have written down. Again, first step was given, second step was multiplication property, third step distributive property, fourth simplify, fifth subtraction property, sixth simplify, again, seventh subtraction property. Wow, my writing is not very clear, y'all. Then simplify again, then division property, then simplify again, okay? All right, so pause the video, come back to me, and then we'll do the we do one. Okay, so for the we do one, this one's a little bit different. But with step 2 here, again, I'm going to, let me change colors here. Step 2 here, I'm going to get rid of that 1/2 again. So I'm going to multiply by 2, the 1/2 y. And that's going to be equal to 2 times 6x minus 10. Now you could divide by 1/2, but I don't like dividing by 1/2, so I'm going to multiply. Okay, so again, our first step was given, right? Our second step here, what did we do again? We did multiplication property, right? Multiplication property. Okay, we're going to use the distributive property again, right? So we're going to go 3 here. So this is going to just be y. And that's going to be equal to, because 2 times 1/2 is, and here we're going to do 2 times our 6x minus 2 times 10, or plus 2 times negative 10, whichever way you want to do it, okay? So here again, step 3, this is the distributive property. Okay, step 4, let's go ahead and simplify. Okay, y is equal to 12x, and I'm going to do minus 20. Okay, so I'm going to leave it right there, and I'm going to say this is 4, so we just simplified, right? Now the next step I'm going to do is I'm going to actually substitute in that 2.5 so that I can find y. Okay, so for step 5, I'm going to say y is equal to 12 times 2.5 minus 20. Okay, so this is going to be substitution property. Okay, so here again we're going to simplify. So I'm going to say y is equal to 12 times 2.5 was 30 minus 20, right? So this was the multiplication property. Sorry, step 6, multiplication. Okay. Step 7, we're just going to subtract the 20 from the 30, right? So y is equal to 10. So that is simplify, okay? Okay. So there's all your steps. Again, if you need to pause the video so you can write them all down, then go ahead and do that. We went from kind of hard to a little bit easier, right? So again, our first step is given, okay? We were given that piece of information, yes. Okay, so then what are we going to do for step 2 here? I'm going to multiply by 2 again, 1/2 t, and that's equal to 2 times -7. So again, this would be our multiplication property. Okay, now this time I'm just going to say simplify, okay? So 3 here, I'm going to say this is t is equal to -14. So that 3 is just, all I did was simplify, right? And I'm done. 3 steps. Ooh, after the first 2, that seemed like really, really easy, right? Okay, so now you guys are going to go ahead and do the you do one. Okay, so pause the video here, do the you do one yourself, and then come back to me when you're done. Okay? Okay, so again, our first step is given. So step 2, probably most of you, what you did was you added 6 to both sides, right? So 5x minus 6 plus 6 is equal to 4 plus 6, right? So my step 2 here was what? Addition property. Okay, then step 3 is going to be 5x, and that -6 and 6x are going to simplify, right? So this is going to be equal to 10. So we're just going to say we're simplifying, right? Okay. Step 4, what are we going to do next? We're going to do the 5x divided by 5, right, is equal to 10 divided by 5. Remember, whatever we do on the left, we have to do on the right. So what do we just do? The division property, right? D-I-B-I, wow, I can't spell today, y'all. D-I-B-I-S-I-O-N, property. Okay, and then what are we doing for our last step? Simplifying again, right? So this is just going to be x equals 2, right? So step 5 was simplify. Started out hard and got our way easier. Kind of like that, right? Okay. So the next thing I got to teach you guys about is the reflexive, symmetric, and transitive properties. So this is one of the things I tell my kids when I teach this is remember R, S, T are in the order of the alphabet, right? R is 1, S is 2, T is 3 or more, okay? R, S, T, 1, 2, 3. So I want you guys to commit that to memory. R, S, T, 1, 2, 3. And you're going to understand why in just a minute as I go over this, okay? Now this is new stuff. The things we just did were pretty, common, okay? We know what those things are. So with this first one, we're going to say A is equal to A, okay? So what does that mean? So this is the same thing on both sides of the equal sign, okay? So that means if the measure of angle A is equal to the measure of angle A, okay? Or we can say segment AB is equal to segment AB, okay? And we can use this with equal signs or congruent signs, okay? All right, so that's the reflexive property. Notice it's the same exact thing on either side of the equal sign, okay? Now, when we talk about the symmetric property, if A equals B, then we can also say what? B equals A. So what do you notice happened? They flip places, right? And there's 2 different things this time. The first time there was only one thing, right? This time there's 2 different things. Okay, so now when we talk about this, we're going to say the measure of angle A. If the measure of angle A is equal to the measure of angle B, then what could we say? So the measure of angle B is equal to the measure of angle A, okay? Now, how else could we say this? We could say this with segments. So this one, now watch this one. So we could say, or AB, segment AB is equal to segment BA. So what did you notice happened? They flipped, okay? So that is the key with this symmetric property, okay? It's kind of like things flip with it, whereas reflexive is just a mirror image. It's the exact same thing on either side of the equal sign, okay? Notice the difference here. I need y'all to look right here. Notice the difference here and here. Okay, when it's reflexive, it's the exact same thing on both sides of the equal sign. When it's just symmetric property, things are flipping, okay? All right, so now the last one is if, this is 3 or more, remember, A is equal to B and B is equal to C, then what could we say? Then we could say A is equal to C, right? So if, like, for example, if we said X is equal to Y, I'm going to do this with some, if X is equal to Y, and when I tell you that X is equal to 1, then doesn't Y equal 1? That's an example of that, okay? Specifically there, okay? So now, let's talk about this with angles. So this time we're going to say if the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then what could you say? Then you could say the measure of angle A is equal to the measure of angle C. Notice we have 3 separate items here, right? Angle A, angle B, and angle C, okay? So if we say angle A and B are congruent and B and C are congruent, then obviously angle A and C have to be congruent, okay? Now we can also do this with segments, okay? So this time we're going to say if AB is equal to CD and CD is equal to EF, then can't we say that, so AB is going to be equal to EF, right? So this is just like with those numbers a minute ago, right? So if we knew that AB was equal to 1 and CD is equal to it, then it has to be 1. If CD is equal to EF, then all of them are 1, okay? That's what this communicates, okay? And you're going to understand it more as we use it, okay? So now we're going to talk about actual proofs. This is a 2-column proof, okay? So in this 2-column proof, it says it's given that M is parallel to N. And we can see that because we have arrows up here. Y'all see these arrows on lines M and N? That's what those arrows mean, is that those lines are parallel. It says that we're going to prove that angle 2 is congruent to angle 6 by corresponding angles. Okay, so here's the key. So this piece of information right here, like I said, it's usually our first statement. So we're going to write given right here. And notice down here for step 4, that is what we are trying to prove. Y'all see that right there? That angle 2 is congruent to angle 6, okay? So we're given the first piece. Now let's look at this. It says that angle 2 in this drawing, angle 2 is congruent to angle 8. So we've already learned about this. You guys may or may not remember it because it's been a minute, okay? Why are these angles congruent? So are they on the same side or alternate sides of our transversal? L is our transversal, M and N are our parallel lines, guys, okay? So aren't these alternate? And aren't they exterior to the parallel lines? Exterior angles, okay? These are alternate exterior angles, okay? And that's why they are congruent, okay? Then it says that 6 is congruent with 8, okay? So let's look at 6 and 8. So it says 6 is congruent with 8. So why is 6 congruent with 8? These are vertical angles, aren't they? These are our vertical angles, and vertical angles are congruent, okay? Okay, so you guys are going to have to be able to recognize alternate exterior angles, vertical angles. We've already learned that those are congruent, right? Okay, so then why are angles 2 and 6 congruent to each other? So I want you to look right here. We just talked about this. 2 is congruent to 8. 6 is congruent to 8. What do you see repeated here? Do you guys see angle 8 repeated? So what happens when you have a repeated angle, you can take it out and you can say that 2 is congruent to 6. And this is an example of the transitive property right here, okay? This is the transitive property. Okay? That's what the transitive property is when we have 3 different angles that are congruent to one another. And even in the drawing, you can see that, because see the 2, the 6, and the 8? And so that's how we know that was the transitive property as well. Okay, on our next one here, it says alternate interior angles congruence. So here again, it tells us that P is congruent with Q. How do we know that? This was, again, given information, right? Now, what is it we're trying to prove? I need you guys to see this here. Whatever we're trying to prove is always going to be our last step. So angle 1 is congruent to angle 2 down here is what we are trying to prove. So that's always going to be our last statement, okay? Our reasons are on the right, our statements are on the left. Okay, so I want to look for a pair of corresponding angles in this drawing. Corresponding means they're on the same side of the transversal, on the same side as the parallel lines, okay? So I notice that angle 1 up here is congruent with angle 3 because they are on the same side of the transversal and the same side of the parallel line. So I'm going to put here angle 1 is congruent with angle 3. Okay? So once again, now we're going to look at this next statement. Why is angle 3 congruent with angle 2? We just did this one in the previous proof. So why were those two angles that are opposite each other and form V's congruent to each other? Because they are vertical angles, right? Okay? All right, we got one more, y'all. So this time we're going to prove the vertical angles congruence theorem, okay? So this time it says again, given lines K and M are intersect, prove angle 1 is congruent to angle 3. So we know that this piece up here is given, and what are we trying to prove? Angle 1 is congruent to angle 3, okay? So now we're going to work through each of these steps. So it says definition of a linear pair. Well, what in the world does that mean? A definition of a linear pair means that two angles are going to be supplementary. So we can say that angle 1 and angle 2, and look at the next step, this helps us. Angle 1 and angle 2 are supplementary, right? And angle 2 and angle 3 are also, I'm just going to put tick marks here, supplementary. Y'all got me? So notice 1 and 2 up there and 2 and 3 form lines, yes? So the next statement says the same exact thing, but the first one was a definition of a linear pair. The second one is a linear pair theorem. So we're going to write linear pair theorem here. And we already learned this, right? That when you add those two angles together, that is a linear pair. Okay, so what are we going to do for the next one? This is a definition of supplementary angles, okay? So when we're talking about this, we're going to say the measure. Now, we're going from an angle to a measure. So measure of angle 1 plus the measure of angle 2 equals 180, right? And what else? And the measure of angle 2 plus the measure of angle 3 also equals 180, okay? Yes, I know this seems a little redundant, but it is how we work proofs, okay? So now, what do you notice on both sides of the equal sign above? What do you notice? So, do you guys notice that we've got the 180 here and the 180 here? That means that we can substitute in the other side. So this next step right here is the substitution property. Actually, let me do it in red so you guys can see it. Substitution. Because we basically substituted in the the measure of angle 1 plus measure of angle 3 for the 180, okay? So this is the substitution property. And the more we do this, the more it'll make sense, okay, y'all? So then, I need you guys to notice what is different between 5 and 7. And it says on the right that it's the subtraction property, okay? So what do you think was subtracted to get to where angle 1 is congruent to angle 3? So y'all notice 2 and 2 need to go, right? So if I subtracted the measure of angle 2 from both sides, I get the measure of angle 1 is equal to the measure of angle 3. Y'all see that? Now, the only difference between steps 6 and 7 is we have measurements versus a congruent symbol, okay? So anytime we go from equal to congruence or congruence to equal, we're going to say definition of congruent something. Could be congruent angles, could be congruent segments. Y'all got me? Most of the time it's going to be congruent angles, but if it says definition of congruent angles, that could be going from equal to congruence or congruence to equal. Okay? That's it.